Well, thank you very much.
Sorry,
Thank you very much, Barb, for this wonderful introduction, and thank you all for being here.
one more thing. Get rid of this.
All right, great. Okay. So today, as Barb said, I'm going to be talking to you about how you can detect, first of all, and then account for differences in answer reliability on self-reports, which people give you. This is one of the first times I'm giving the talk, and the first time I'm giving it to such a diverse audience. So please feel free to ask me questions at any point in time. And I'll be very happy to take those and to answer those as far as I can and to take notes on useful suggestions. So first of all, why should you care about this topic? Well, there is extensive evidence that all of preferences and personality and other latent skills are key determinants of outcome heterogeneity. And a lot of people here at UPenn have been doing interesting work on this. Barbara, Angela Duckworth, Petra Todd. We have a recent book chapter with Jim Heckman and Tim Kautz, which summarizes the evidence. Now, for these, self-assessments are an important source of information because you can't observe the skills directly. And on self-assessments, the reliability of answers is a key problem. There's a recent and growing literature on this issue. However, we thus far have an incomplete understanding of the sources and the amount of measurement there in standardly used, even in standardly used survey questions. And the current methods which we have at our disposal often require either many measures, panel data, or are cumbersome to implement, or all of the above, in order to address measurement error problems. So this brings me to the research question which I'm going to try to answer today, and which is how can we detect and account for heterogeneous measurement error in individuals' answers on commonly used qualitative tasks designed to elicit preferences, personality, and well-being. There are three key contributions which we bring to this issue. First, we quantify differences in answer precision across individuals. Second, we clarify the role that effort and imperfect self-knowledge has in these differences in measurement error and answer precision. And finally, and most importantly, we propose a simple and novel measure for self-reported reliability and demonstrate that it is the single best predictor of revealed reliability. And I'll explain in just a little bit what I mean by that. I'm going to talk about quite a few things here, so I'm just going to give you a brief outline. I'll start with a description of the data. Then I'm going to talk about test-retest correlations as being an indicator and a measure of measurement error. And then I'll present a twist on the common general test-retest correlation concept, which will allow me to talk about measurement error, not across individuals for a given construct, but for a given individual across constructs. And I'll introduce our novel self-reported reliability measure. And I'll talk about how that can be used to address attenuation bias, which results from having noisy measures of explanatory variables. And finally, I'll talk about what we learned tells us about the sources and potential mechanisms for measurement error. I'll present a simple model which rationalizes these findings. All right, so our data comes from a two-wave data collection, which we did through the Donata platform. So it was an online survey. And we had 1,400 individuals answer the survey in the first wave, and 651 of those completed both survey waves. So the first wave and the second wave. We have respondents from 4 major English-speaking countries: Australia, Canada, United Kingdom, and the United States. And they're a pretty young sample, ages 18 to 25. Now, we varied the delay between the recontact, so between the first and second wave. It ranged from 2 to 11 weeks, and there's a median of 5 weeks. And I'm going to use that to support the assumption of construct stability between the 2 waves. So in our survey, we have standard questions, which are used to measure personality. And here we're using the BFI 260 item questionnaire, but also a 16-item ZERB question, which is implemented in the kind of widely used German socioeconomic panel data set. We also have qualitative questions for eliciting economic preferences, implemented in the World Preference Survey. We have 2 scales for well-being, and then we have a number of questions for ability, cognitive ability specifically. Finally, and this is, again, the main contribution, we introduce 2 novel measures for self-reported reliability. We're going to show that they're pretty effective. Now, our data collection involves a couple of experimental treatments. On top of kind of the regular survey fees that individuals receive from the NADA, we're giving them randomly either free or $6 equivalent in local currency. And some people don't get anything extra. And then we also randomize the order in which we ask the various survey components. Now, I think a lot of you might be familiar with the concept of test-retest correlations, but just because we're talking to potentially quite a broad audience here, I'm going to go briefly over what I mean by this. So first, what you need is you need to elicit the same construct repeatedly within a short enough time period, such that the underlying latent constructs that you're interested in can reasonably be assumed to be stable for a given individual. And this is something that's often used by psychologists as an indicator of a measure's reliability. One of our contributions is that we provide test-retest correlations for self-reports which are most relevant to social scientists. This is just a brief illustration that the assumption of construct stability holds, which at least supports that assumption, that construct stability holds within the time frame between our 2 survey waves. So what I'm showing you here are test-retest correlations and the impact of the differences in recontact time on them, right? So if you thought that these things, the underlying constructs, they're changing over time, then you would expect, and that they're changing kind of even within this time frame, then you would expect individuals who have a wider time span between the 2 survey waves to have lower test-retest correlations than those who have a lower one. And we actually find no evidence of that at all, right? So if we regress test-retest correlations on recontact time in days, coefficient is 0.00. If we split the sample kind of in the middle, so again, the range is 2 to 11 weeks for recontact. If we split it at 6, we find a very weak and completely insignificant negative coefficient. Now, the fact that the coefficient is negative, so that makes sense, right? At some point, these things will be changing, but there's no evidence that these effects are important or that they would explain any of our findings within the time period that we're looking at. And the strategy that will follow of our paper is that we take test-retest correlations for each construct, and we'll use it as a benchmark for the measurement error content of that construct, right? So if these constructs are stable, I've given you some supportive evidence for that, then you'd expect test-retest correlations to be 1 within this short time period. And any difference from 1 we'll be attributing to measurement error. Then we'll do a twist on this concept, as I advertised, to construct an individual-specific revealed reliability indicator, so revealed from the individual's responses. And we'll measure the impact of a number of things, such as survey design, incentives, experimental conditions, and individual characteristics on test-retest correlations. And we'll identify the conditions under which measurement error is minimized on qualitative surveys. So this is kind of our goal. Okay, So here, just a brief summary of the test retest correlations that we find. So for the 60-item personality questionnaire, we find the highest test retest correlations, 0.82, averaged across the 5 traits. When we look at life satisfaction across the 2 constructs, we get a test retest correlation of 0.75.
Really want to deconstruct the letters and the tests that you're using. People might not know what those are.
Sure, right. So BFI2 questionnaire. So it's called the Big 5 inventory. It's got a number 2 because it's kind of sort of personality questionnaire. And thank you for asking me to clarify this. There's various classifications used in psychology. I think the Big 5 is one of the most influential, which sort of characterizes individuals based on 5 personality traits. So that's extroversion, conscientiousness, agreeableness, openness to experience, and emotional stability. And these should be orthogonal, and they should kind of be representative of differences in individuals' behavior. And this is one of the standard ways of eliciting them. This is one of the more extensive questionnaires. So there's 12 questions per personality trait. And these can be further subdivided into facets. Now for life satisfaction, right? So it's basically asking you 1 or 6 questions. How satisfied are you with your life in general? The ZERP personality trait. So that's the same thing as the Big 5 inventory, but it's much more tractable. There's 16 questions, so it's 3 per trait and 4 for one of the traits. That's using, again, this influential German socioeconomic panel that a lot of people use. And here, this is one of the things that are actually interesting, right? Why do they use the shorter questionnaire? Well, because they want a lot of information from people. There's limited time that they can have people for. So these are kind of the data requirements. And we see that here that test retest correlation is lower than for the more extensive questionnaire. Then we have questions on cognitive ability, which are basically asking people to self-evaluate their ability to use the computer, write, read, communicate, math, problem solve. So all of these are qualitative self-reports. And here we find a test retest correlation of 0.64. Finally, we have qualitative questions. So these are single questions eliciting economic preferences. These have the lowest test retest correlation of 0.56 across 9 preferences. So there's preferences for risk, time, social preferences, etc. Now, when you're looking at these, you might be tempted to, for example, to conclude that the personality traits, that they're somehow better or more stable than the economic preferences. Now, before you make that conclusion, I would just like to go back to that basic fact that here we're using 12 measures per trait. Here we're using about 3 personality, lower test retest correlation. For the economic preferences, we have 1 measure per preference, right? And if you actually look at the test retest correlation to the single questions, used to construct these higher overarching constructs, then the test retest correlations are not so different. And that is kind of intuitive, right? If measurement error is random noise, then increasing the number of measures should improve the precision of the signal. I'm not saying anything novel here, but hopefully the quantification that I'll show in just a little bit might add some value to the debate, right? And what we find, so what we do is we take the Big 5, the 60-item Big 5 inventory, where we have 12 measures per trait, and we look at differences in test retest stability. If we just take 1 measure per trait, we take all the 1 measures per trait and we average for the test retest stability, and then we take all combinations of 2 measures per trait, 3 up to 12. And we find that when we're going from 1 to 12 measures, test retest correlations increase by 0.26, so that's quite a lot. And that is approximately a 50% reduction in noise. And this is kind of just showing that graphically. And to us, again, nothing super surprising here, but just an interesting quantification of the relationship empirically. So here you see for each of the 5 Big 5 personality traits, you see how test retest correlations are increasing. So the measurement error content of the responses is decreasing as you're aggregating from 1 to 12 measures. And this is just a comparison of what you'd expect in theory, right? So if you're eliciting the same construct and you're getting some error draws on it, and then you're averaging over 1 to 12 elicitation. So it looks very similar, right? Monotonically increasing, it's concave, so you get the most bang for the buck at the beginning. And this is what we're going to use to benchmark the effectiveness of our self-reported reliability indicator. Right? We're going to say, if you use our indicator, you focus on the people who are actually self-report to give reliable answers, what is the improvement in precision that you're going to achieve in terms of just the alternative that you could use, just increasing the number of measures per turn? Yeah, please. So this would be right for each of the personality traits. So these would be ideally just different ways of asking about, say, the extroversion personality traits. So do you have one question about it, 2 questions, 3, 4, 5 to 12? Right. So this would be related to how kind of social you are, active, excitement seeking, all the things that we think go into the extroverted personality trait. And the assumption here is, again, that each of the measures is being driven by the same latent unobserved construct that you're interested in, extroversion, but it has some error on it. All right, and then if you're averaging over more measures, you should be getting the more precise.
And the way that you look at test context, you're seeing that these measures of function.
So all I'm saying for the purposes of this talk is within the 2 to 11 recontact time period, these things are safe, right? And presumably there's some literature on like various life events being able to change these. However, fundamentally, I think psychologists and economists for preferences and personality were assuming that these are reasonably stable person-specific indicators, which for sure they'll change a little bit over time. But I showed you that within our time period, we see no evidence. It's a short enough time period, basically, to assume construct stability. And that's key for arguing that test-retest correlations, they're giving us, well, the inverse of measurement there. Thank you for the question. All right. Now, so I've shown you the relationship between measurement there and the number of measures. Now, measurement there and survey time. Here, there are actually competing hypotheses. One is kind of the effort hypothesis, right? Which would predict that the more time that people spend on the survey, the more accurate, more reliable responses you're going to get, simply because you're taking the questions more seriously. Now, there's another hypothesis, which I'll call the indifference hypothesis, which is saying that additional time spent on the survey, that's really reflective mainly of the fact that people aren't sure how to answer. And in that framework, you would expect more time, all else equal, to be giving or be indicative of less reliable responses. And our results support the effort hypothesis with a twist. And here's the twist. First time we saw this chart, like we thought it's pretty striking. So what I'm plotting here is test-retest correlation. So again, inverse of measurement there on the vertical axis. On the horizontal axis is decile by time taken to complete the survey, right? So further you go along the horizontal axis, more time you take. What we observe, consistent with the effort hypothesis, is that at the beginning, taking more time indeed is indicative of more reliable answers. However, we find that there's a threshold, and that threshold occurs very early on. It's about the 5th percentile of survey responses in our survey, around 2 seconds per task. Again, these are simple survey tasks, right? And beyond that, we see no additional gain in terms of the reliability of answers in terms of time spent.
And you think that's consistent with the effort hypothesis? Do you think your effort hypothesis would show a functional relationship all the way across.
Well, so it depends on how you think effort is working. And so the simple model, which I'll present at the end, which rationalizes that all that we will have learned is that there is a certain threshold, right, which individuals need to cross and which is indicative of them engaging seriously with the survey, right? So if you're below that threshold, then you're kind of just randomizing, but whatever. Once you're above that threshold, you've read the question. These are rather simple questions. So you've engaged with the survey seriously, you've put in the effort necessary, and the additional time, I'm not going to say exactly what that's equivalent of, but what we're suggesting is that once you cross the effort threshold, you've engaged seriously with the survey, then the reliability of your answers is no longer constrained by effort, it's constrained by something else. And we're going to call that self-awareness or self-knowledge. Right? At some point, no matter how much effort you put in, if you're not sure about what the right answer is for you, then additional time is not going to help you anymore. So that's the way we sort of use it, please.
I'm wondering what you did to screen out like automatic really thought responses, because couldn't that be the people who have the really short response time?
So I'll talk about this later. What the survey provider does is they screen out actually responses based on survey patterns. So for example, if people streamline, they also screen out responses at extremely short or extremely long survey responses. But what we're saying here is that it seems that their criteria are insufficient. Right, so this would be after some very preliminary screening out by the survey provider. But clearly, I mean, their motivation is they want to, I guess, screen out as few respondents as possible so that they get paid for as many as they can. And that's why, so the 5th percentile, that it's after some screening by Donata, that's why we also say that it corresponds to about 2 seconds per survey question. It might be the more general result here. And in accordance with this, we define a rushing variable, which represents the individuals below the threshold. And we show also if you take a regression and you run measurement there on even a polynomial, so time spent and time spent squared. Once you put in the dummy, it's no longer significant. Without the dummy, it is significant and positive. So you'd say, oh yeah, after. We're just giving the more nuanced view that there's a threshold. That's what it seems. All right, now just very briefly, since I told you I have a couple of treatments here, they don't do much in terms of measurement there, okay? Providing extra incentives slightly increases time spent on the survey. The median time rises by about 2 minutes. And doubling the extra incentive in the second wave has no impact. Now, the interesting thing here is that the increase in survey time is concentrated really kind of at the upper tails of the distribution. So the rushing probability is ineffective, which is why we think that that's why we don't observe any increase in test-retest correlations or decrease in measurement, right? Because these people who just rush through the survey, we don't seem to be very effective in kind of getting them to change their behavior with these incentives. Just a couple of interesting correlations. Extra incentives report the mood that people say they're in at the beginning, improve the mood, especially at the beginning of the survey. And we find no evidence of priming or survey fatigue as question order is irrelevant to our results. We also find that test-retest correlations are invariant too. Recontact time, taking the test on a PCR and handheld device, and gender. So now we're getting to the interesting stuff. We introduce a self-reported reliability question, and we measure it twice. First, at the end of the personality section, right? So these go, and I'm someone who, and you have a list of like 60-some statements on the big 5 personality traits. We add one more. At the end, we ask, I'm someone who is sure that my answers to the survey describe me accurately. Okay, because it's at the end of the Big Five inventory personality questionnaire, we're going to call this BFI reliability. We ask again at the end of the survey, or we simply ask people to indicate how reliable on a scale of 0 to 10 their answers are. We call this overall reliability. Now, we find that the self-reported reliability of answers on the survey overall is high, but it's heterogeneous, importantly. So out of the 651 individuals who completed both survey waves, almost 60% recorded a self-reported reliability at the top of the scale for the personality, BFI reliability, and over 70% in overall reliability of greater than 9 out of 10. What we do now is we're testing whether the self-report is doing what we want it to do, right? Whether it can help us separate the individuals who give highly reliable responses from those who do not. And if self-reported reliability is a good proxy for the actual reliability of answers, and test-retest correlations are a good inverse proxy for the degree of measurement error in respondents' responses, we should observe higher test-retest correlations for individuals who self-report to give reliable answers. And this is what I'm showing you here. What you can see is that across the constructs we're measuring, so the 60-item personality questionnaire, the 16-item personality questionnaire, single economic preference measures, 2 life satisfaction indicators, and various ability indicators, people consistently who self-report to be reliable also have higher test-retest correlations or lower measurement there, right? So the rows in red are the rows in which the individuals who say they're in the first 2 columns sure about the BFI responses, and the last 2 columns who self-report to give overall reliable answers, that we find for them higher test-retest correlations for each of the constructs, and for those who self-report not to give highly reliable answers. Okay. And we find this for the personality question, all constructs, for the overall reliability, 26 out of 20.
Thomas, why do you go back to the previous slide? Why are you separating the pink column from the white column? Why aren't you just getting correlation between the reliability for that person and their response on the reliability question?
So I'm going to show you that in just a little bit when we're going to talk about individual revealed reliability, right? So these test-retest correlations, what they're doing is you take everybody's responses on, say, extroversion, and you correlate the responses in wave 1 across individuals with wave 2 across individuals. And here I'm just saying, well, let's look at the people who self-report to give highly reliable answers and those who don't.
I see.
Yeah. And in just a little bit, we're going to get to the individual reliability indicator, which is also, we think, a novel contribution for us. But before we get to that, so this seems to be effective. We also looked at a continuous indicator. If we regress it on the test-retest correlations, that's significant for 23 out of 27 examined constructs. Now, we find that the personality self-reported reliability question does a little bit better. So here, the average difference in test-retest correlations is 0.13 versus 0.11. But regardless, whether they're pretty close. So the difference between the reliability of answers of individuals who self-report to give reliable answers and those who don't, so that is comparable to the difference obtained by increasing the number of measures per trait from 1 to 5. Remember that chart I showed you, or from 3 to 12 per trait. And that's the same just because there's a concave relationship, right? So you're getting the most bang for the buck at the beginning. Why we think the 3 to 12 is interesting is because what we're basically showing you is that you can take the free item per trait ZERP questionnaire And in conjunction with our self-reported reliability indicator, obtained a 12th item BFI2 reliability with much lower data requirements. And another interesting thing here is, right, that what I've shown you is that these self-reported questions, both of them are predictive across the elicited measures. And this was a little bit of a surprise to us. We thought, maybe the personality one, right, the one we ask at the end of the personality section, maybe that's going to be more predictive of personality responses. The overall one, maybe up the overall responses. We find that both of them are predictive across the table. And what this is suggesting to us is maybe we're getting at a more fundamental trait that we're measuring, which is related to just the reliability of answers that people give, which itself might be measured with error. And some support for this is that correlations that we find between the two reliability questions are similar within a wave and across waves. And if we combine the two reliability questions together, sort of like you're adding different measures for extroversion, we find a higher test-retest correlation, right? So in the correlations between the two self-reported reliability measures are about 0.44, which is actually in line. It's not, it is within the range of test-retest correlation for single measures of the construct that we have, the 87 constructs. And the test-retest correlations are 0.44 for the BFI measure, about the same for the overall measure. And if we combine them, we get a test-retest correlation of 0.43. Please. Well, we're suggesting that asking the people is much more psychopathic, right? Because you give one question. And you can filter these people out. And in just a little bit, I'm going to show you what this looks like when you're actually looking at important life outcomes and what we can achieve with this question. Yeah, that's what we're gonna. It's actually, we were kind of surprised by how effective that is.
How do you think about this self-reported reliability? Because you could think of it as just people could be spending time on the survey but not taking it seriously. Survey while watching. Or you could think that some people just surveys say that it's some future person. I guess this could be measuring some feature of the way in which they responded on this particular survey. It's nonetheless going to be correlated across time. And take surveys, maybe they're not very conscientious, and then take surveys while they're doing other things. Or it could be something sort of more stable about the person. Distinguishes it, or if it's maybe
Wow.
You're just using this as of like saying here's good responses, here's bad responses. Let's just look at the data.
Sure. So I think that's a relevant question, and I will talk about it more. Just a quick preview is we think it is capturing both. So what we'll be talking about, or the evidence we find, is consistent with both efforts and kind of self-knowledge being important. Determinants of reliability. We correlate both self-reported reliability and the revealed individual reliability, which I'll present in just a second, the various characteristics, etc. And we're kind of going to tell a story and develop a simple model of how we think, why we think this happen. And just with other research on the topic, which suggests that this might be more, like maybe an additional relevant characteristic that we want to know about people. is, for example, I gave a talk yesterday in the econ department here, where I was talking about connecting the way economists and psychologists view human differences, so economic preferences and personality. One of the things I look at there is, so I'm looking at incentivized economic experiments. I have also a questionnaire. And for the incentivized experiments, I also see choice inconsistency. So I estimate basically the scale of the error shock that would explain this for various people. And my interpretation is that it reflects differences in self-knowledge. And I find that both for risk and time preferences, this is correlated with a particular personality trait, or best explained by conscientiousness, right? More conscientious individuals seem to have better self-knowledge. Now, Yank and Graeber papers that I'm citing here, so these are two young economists over at Harvard, they're doing something similar. They give people these incentivized economic choice tasks, these skills at risk and time preferences, and they ask, how sure are you of your answer? They find that how sure people are of the risk answers is correlated with how sure people are of the time answers. Again, the two questions we asked here, different points in the survey, they're predictive of kind of reliability across the measures, which is why this is all evidence that is suggesting to me that we might be talking about some more fundamental characteristic here. Now, this is just, I apologize, these are small, but I'm not expecting you to read this really, but look at the red and the white. So this is the same table, just reproduced. The first one, we exclude individuals who rush the survey. That's just to demonstrate that our question captures more information than simply, the time record variable. In the second one, we only use information from the first wave answers, right? So in the first table I presented, we were looking at individuals who self-report to give reliable answers on both survey waves. Here, we're only using information from the first wave. Why? Because our goal here is really to give researchers a simple tool that they can easily implement in cross-sectional data without requiring multiple observations. So now you see that there's, before there was one white row, now there's three. So we are losing a little bit of information by only looking at the first wave's self-reports on reliability, but we still find that to be quite effective. And in fact, in the analyses of outcomes and the improvements which we achieved there, I'll only be using the first wave measure and only one first wave measure. All right, so how does all this work, right? What's the problem with measurement there? Just very briefly, I'll go over the attenuation bias framework. Please ask me if, this might be super familiar or not so familiar, so please let me know. So assume that you have a latent or unobserved explanatory variable x, right? Say extroversion, you don't observe it directly. You only observe it with some error. So you have x hat, which is x plus mu, where mu is an error term. Now, you take an outcome y, which you think is being driven by x, the true x. And there is an equation error term, right, which represents the influence of unobserved variables. Now, if we assume, for the sake of argument, that the explanatory variable x is uncorrelated with the equation error term, and that the measurement error mu is mean 0 and uncorrelated with everything else here, x, y, and the equation error term, then we get the classical errors in variables one, right? And what that does is once you substitute x hat, which has the error term instead of just x, you get basically a form of endogeneity bias. And it's a specific form of endogeneity bias because your estimator of beta hat converges to the true estimate beta of the coefficient on your explanatory variable times a term which is between 0 and 1. It's less than 1 anytime that the variance of the measurement error shock is positive, right? So as soon as you have measurement there, you're getting coefficients biased towards 0. That's attenuation bias. So that's why it's a problem. And one of the things I sort of hope to have shed some light on in the talk yesterday was the puzzle that before we found that economic preferences seem to predict outcomes, personality seems to predict outcomes, but when we correlated those in very simple reduced form measures, not taking noise into account, we found no relationship, even though we thought there logically should be one intuitively. And I'm suggesting that's more due to measurement issues, then really no relationship. And attenuation bias is one thing that explains that, right? You're correlating two latent constructs, measurement error in one, measurement error in the other. You're unlikely to find very strong results, even though they might exist. Now, what I've shown you thus far is just a very crude division of individuals into those who we classify as reliable and unreliable based on their self-reports. And we find that works reasonably well. So I'm going to propose a model with two unobserved types. There's a reliable type and an unreliable type. And what they'll be characterized by is differences in the variance on the error term, on the explanatory variable, right? So the reliable type has a lower variance than the unreliable. In fact, just for the sake of this quick argument, so we find that the unreliable type has much higher error variance, measurement error. And for simplicity, we'll just assume that for the reliable type, there's no measurement error. Okay, that's not exactly true in practice, but for the sake of argument. If we assume this, it is the unreliable type who is introducing attenuation bias into any estimates of the impact of an explanatory latent noisy explanatory variables X on an outcome Y, which means that estimated coefficients, these statistics, and the equation R squared, so the explanatory power, will be biased towards zero compared to what is true. And the bias will be increasing in the noisiness of the responses of the unreliable type, and also in how frequent the unreliable type is in your sample. All right. So what we want to do in this framework, right, it suggests that you need to identify and exclude the unreliable type. Now I'm going to show you some evidence that our self-reported reliability indicator does to some approximation. But before that, there's a last concept that I'll introduce, which is the standardized individual reliability indicator. That's just going to be a twist on the general test-retest correlation concept, which fails to capture differences in answer reliability across individuals. So what we'll do is we'll take for each individual a vector of normalized scores for the 87 questions that we ask: preferences, personality, life satisfaction, ability. And this will give us two vectors for each individual, right? For the first wave and the second wave. We simply correlate. That's going to be our individual revealed reliability indicator. That's going to be indicative of the consistency of an individual answers across the survey. We're going to use it as a benchmark for self-reported reliability. And this is what we find. So here we're regressing the revealed individual reliability indicator on self-reported reliability. There's a few takeaways. First of all, self-reported reliability is highly predictive of revealed individual reliability. And the R squared is at a surprisingly high. For a simple question, it's 0.16. Now, the first column is the personality question for reliability. The second column is the overall reliability question. Now, the scales here are different, so the coefficients are actually roughly the same size. But you'll see here that the R squared is about twice as high for the BFIs, for the personality indicator. And we sort of find kind of in various ways we're looking at it. We find both of them to sort of be measuring the same thing, but the first personality question and its different wording, we find that to be more effective. And so again, consistent with our goal, kind of giving one question that you can ask in one wave of data, we're going to show what that does to your results. And here, the last column, it just shows that if you have both of them in, the increase in R squared, not so big over just having the personality one. Both are positive and significant, and then the interaction term is also positive, right? So they do seem to be related, but for some reason, the personality question seems to be a little bit different. Yeah.
What's the correlation between the two self-reported reliability?
So I think that was about 0.4 something. That's what yeah, it was about 0.4. That's what I had like the slide where I was saying it looks like a characteristic that is sort of in line on the lower end, but in line with single item test retest correlations for these various questions. What this slide shows is that not only is self-reported reliability predictive of individual revealed reliability, it is the single best predictor that we find among all the things that we measure in our survey. And it is predictive and significant even after you put in experimental treatments, whether somebody rushes the survey or not, demographics, cognitive ability, personality, and economic preferences. Okay, so there does seem to be something new here. Now, this is an illustration of the effectiveness of our measure in practice. So what we're doing here in our data, we have measures of 4 important life outcomes. So we have college graduation, we have high school GPA, right? These are pretty young folks. We have unemployment, and we have life satisfaction. And we're looking at how well can we predict this. Here it's just PR squared. So how much of the variation in that data can we explain if we put in sort of all that we have: demographics, ability, personality, preferences. And if you recall from my brief discussion of what attenuation bias is doing, right, if you have measurement there, well, it's decreasing a bunch of things. One of them is R squared. It's artificially decreasing explanatory power. So if we are actually getting rid of attenuation bias, we'd expect R squared to rise. So what you see in the first column here, always I'm just showing you the R squared for these. The first column, it's the full sample, and just to re-emphasize, so now we're going into only wave 1 data. So the 1,400 individuals who answered wave 1 data. You'll notice that sometimes there's, well, most of the time there's a little over 1,400 observations. Why? Because we're actually able to add back the observations that do not initially excluded as being kind of low quality data, streamliners or super extreme time outliers. And we just wanted to kind of add them back in, just show what this question does. And in the next table I'll show you is comparing the effectiveness of our method to our methods. And then for life satisfaction, there's fewer observations. This is something that we added midway through the first wave. We kind of, that's on us. And I just thought of that afterwards. So there's fewer observations. All right, but so these are the general patterns. First column for all of these, it's the full wave 1 sample where we have answers on the outcome. The second column, it's the individuals who self-report to be unsure of their answers on the personality questions. The third column is the individuals who report to be sure. If you look at R squared, the differences are pretty big. And especially if you're looking at between the unsure and sure sample, so it's 0.16 to 0.26 for college graduation, 0.3 to 0.5 for high school GPA, 0.4 to 0.9 for unemployment, 0.29 to 0.37 for life satisfaction. Now, this will be a comparison of various techniques that one might use for accounting for measurement there. Right, and some of these are kind of standardly used simple techniques. In the last column, we're actually getting a little more complicated. And you'll see that there's fewer observations here. That's because now we're looking at individuals who answered both surveys. This is just because, as you'll see here, the only techniques that we really find to be effective, or about as effective, or a little more or a little less than our method, are those which use panel data on individuals or repeated observations. And in order to have that, so we need to have, so we can construct them, we need to have multiple observations. Now, in line with the general kind of goal of showing you that our measure is effective in cross-sectional data, for our measure, we're only using information from the first wave on reliability. Okay, but we're taking the sample of the individuals who answered both survey waves for comparability across techniques. So here you have the 4 outcomes. Again, we're looking at R squared, the base sample, that's the full sample, that's in the first one. If you're averaging, simply taking like an average across the self-reports across the 2 waves. That's the second column. Afterwards, it's the NADA's, the survey provider's criterion for excluding individuals based on survey responses. So streamlining, for example, that'll be like the bots maybe, or people who want to make their life easy. And their fast slow exclusion, and combining that together, the observations that they've excluded, what that's doing to our square. There's not much action here. The next column is when we exclude the people who rush the survey. And there isn't that much action either, because we're still excluding quite a few, only just a few people. Well, it's 5%. So that doesn't do that much in terms of overall R squared, it turns out. Now, once we put our self-reported indicator, R squared is going up for most of the cases. And if we combine it with the rushing exclusion, again, not so much action. Now, in the last two columns, we're looking at the method introduced by Falk et al. So Falk, Neubert, and Schreck. It's a working paper 2021, who basically come up with a theoretical definition for detecting people who have good self-knowledge. The way they do that is they're comparing the ratio of the variances of responses in similar questions within a survey wave and across waves, where variation in a wave for similar questions that's slightly different, that should show like nuance and how well you know yourself. So that's good for them in their theoretical model. And then across waves, same questions. If there's variation, that's indicative of lack of self-knowledge. So what they do in their paper, and they actually do something very similar to what I've shown you here, just they calculate self-knowledge for people based on multiple waves of data. And they're saying, well, let's look at the whole sample, below median and above median. Okay, so they do something very similar. They look at R squared. So what I'm doing here is we're looking at people above median on their criterion of self-knowledge using the panel data we have. And we find that's effective, right? So R squared is going up for these questions here. The first question, we do just about the same, a little better. Second question, they do quite a bit better than we do. That's high school GPA. The third and fourth outcome, we're doing a little bit better, right? Just about the same. Okay, so we find their measure to be effective, about as effective as ours, depending on you. Now, an interesting thing is that if we add our self-knowledge question to their theoretical measure of, if we add a reported self-reliability question to their theoretical measure of self-knowledge, we're getting an additional bump in R squared. So they seem to be somewhat complementary. And why we think that is so is that we think self-knowledge is playing in the individual reliability, but we don't think that's the only thing, right? So we think we're capturing actually more than just differences in self-knowledge. The last thing I want to show you here is adding what turned out to be quite an influential paper in economics. It's a recent publication, Gillen et al., calling into mind a pretty old technique to basically use repeated elicitation of the same variable as instruments for one another, right? So wave one for wave two and wave two for wave one. Because you're taking it's the same construct with some error. That's like a good setting. If you have neoclassical measurement there, it's a good setting for IV. That should kind of be the gold standard. However, if we're looking at IV, the R squared criterion does not make sense anymore. It doesn't have the share of explained variation interpretation anymore. And you can actually have negative R squared, for example, with IV. Okay, so we need something different. But as I told you before, attenuation bias should bias that R squared, but also coefficient. So that's what we're looking at now. And we examined the estimated coefficients and the statistical significance of estimates if we apply our technique, the self-knowledge criterion of Falk et al., or the obviously related instrumental variables approach used by Gillen et al. And the cleanest way we thought about doing this is just simply doing regressions of each of the four outcomes on each of the constructs that we have, so extroversion, conscientiousness, risk preference, etc. And just looking at, what percentage of the time are we getting higher coefficients? That would be, again, consistent with eliminating attenuation bias and comparing that across techniques. For our method, we are increasing the absolute magnitude of estimated relationships in 84% of the cases. And again, this is using self-reported reliability from the first wave of data only. The instrumental variables method improves or increases the absolute magnitude of estimates in 87% of the cases, whereas the Falk method does so in 70%. Now, what does this do to statistical significance? And we're actually, so you can have two things going on. One is you're increasing the coefficients. And if you have the same sample size, you'd also be increasing p-statistics and statistical significance. However, the simplest implementation of our method that we're proposing is that you simply exclude the individuals who self-report to be unreliable. So you are, if your sample isn't too big, you are losing statistical power potentially, right? So you might, the coefficient should be higher, but standard errors might also be higher. So then it's unclear what happens with statistical significance. We find that for our method, it's about a wash. It goes up half of the time, goes down half the time. Again, we're using first wave data only. And that's the part excluding a part of the sample. If you apply the instrumental variables approach, statistical significance, you're actually doing quite a bit better there, about 70% it goes up. But if you apply the Falk method, it actually goes down more than half the time. So 42% it goes up. So we are doing a little worse than the instrumental variables method. And we seem to be doing a little better than Falk. And both of those, I just like to emphasize this, but we seem to be improving things. And that's with one single question added to one cross section. Whereas both of these, they require time. Yep. So what the idea is doing, right? We're basically trying to get something that you're trying to find an exogenous variable which is impacting your variability interest and is unrelated to the error in your variable. So if you assume that this is kind of random errors on each of them, on each of the measures, and these are sort of like ideal instruments. Okay. They should be obviously related. That's what they call ORID, obviously related instrumental variables, because it's really the same measure by multiple observations. Measurement there. It should distill, right? If you have multiple measures of the same underlying construct, and if you use one as instrument for the other and vice versa, you should be kind of getting out of that the signal component rather than the error component. And you can read the paper. It's pretty good paper. Again, it's maybe not as original as some people think, but it's a good paper and illustrates nicely that application in a number of settings. If you look at that paper. Okay. Now, one of the things you might be worried about is if you're excluding some of these people, are you sacrificing representativeness of the sample? We actually find no evidence of that. And notably, we find that the reliable sample has full coverage virtually on all observed characteristics, which usually people care about in terms of representativeness. So what this means is, for example, if we have individuals from ages 18 to 25, we're going to observe the full age range both in the reliable sample and in the full sample. Furthermore, differences in means are small between these variables. So between the reliable sample and the full sample, which suggests to us they're not so different. But given that you have full coverage, if you wanted to test that, you could reweigh your estimates, for example. And Falk could help do that. They find sort of similar to us that it doesn't really. Now, we also have, in addition to this, virtually full coverage, also on all the latent traits and preferences, and differences in means are again small, right? So we do find some significant relationships, but they're not big enough to sacrifice representativeness as far as we can tell. So what I'll conclude with, as advertised, hopefully I have just a couple of minutes, is talking about what have we learned about the sources of measurement. So we find that it's decreasing in survey time, but up to a certain threshold, and that it's present to varying degrees, even in individuals who are above that threshold. Right? So it suggests that there's something else going on. And revealed reliability, its variation is correlated with self-reported individual reliability above all else. And this suggests to us that there's something else which is there, right? It's not captured by standard measures of either demographics or latent traits. Suggests to us that there is an additional characteristic, perhaps a trait which is important. We think that's self-knowledge. So just to reiterate this, self-reported reliability is uniquely predictive, it alone, of revealed reliability. The explanatory power dwarfs the explanatory power of demographics. It's larger than the explanatory power in terms of revealed reliability of the big five personality traits and cognitive ability combined. And it's pretty much equivalent to the explanatory power of all the preferences, including the present bias, economic preferences, including the present bias of the data. Rushing the survey, fine, it's the second most important in terms of explanatory power, but it's way back, right? 0.16 compared to 0.7. Demographics, we find a relationship to younger individuals give somewhat less reliable answers. And so if we regress revealed reliability, a bunch of these characteristics, we find some relationships. Treatment conditions have no impact. Now I'm going to talk about the relationships that we find, what they suggest about the pattern. So what we think we're seeing is that the reliability of answers depends on two things. A, how well people are willing to answer the survey questions and how able they are to do so. So first, with the ability to answer the survey task, we think there's an external component to this, which is simply related to the comprehension of the task, right? And the individuals understanding. And we find that there is a positive relationship between higher cognitive ability and conscientiousness and revealed individual reliability. Right, so that suggests to us that these people are likely higher on their ability to understand the text. But we think there's a second part to this. We call this an internal component, and which is self-awareness, right? Even if you understand what's being asked of you, if you don't have that introspection to kind of be able to think, oh, how does this apply to me, right? Then you're not going to be giving very good answers. And we find that openness to experience, that should be related to curiosity, right? You think that people are curious, maybe they engage in more introspection. Age, right? So if you spend more time in this world, hopefully you're learning something about yourself. And conscientiousness, again. So conscientiousness, I put in both of these, so the external and internal component. And that's just because the other research of mine that I mentioned, I find conscientiousness to be a strong predictor also of the consistency of people's answers on incentivized tasks, relative with time preferences. I interpret that as being related to self-knowledge. Now, there is the component of how much an individual wants to answer these questions. Again, external. So that's the perceived benefits of giving reliable answers. We tell people that they're going to get paid no matter what answers they give. There's no right or wrong answers. However, if you're neurotic, highly risk averse, or if you don't trust us very much, you might want to hedge your bets and try to give good answers. And these are the patterns we observe. Now, there's an internal component to this. Some people just want to be nice, and we say we're doing important research and contributing to knowledge, and maybe they just want to help us. Those would be people who are agreeable, maybe high on positive reciprocity, low on negative reciprocity. These are all relationships that we find in the data. And so finally, we do just a little model to rationalize this. First, we assume that people are benevolent to the researchers, so they're not trying to actively deceive us, and they have no real incentive to do so. And we also assume that while individuals have imperfect self-knowledge, they have at least some level of self-knowledge, which basically means that their answers are centered around somewhere the true response, but with some variation. We also assume that people need to exert effort in order to give good answers, and how much effort they need to exert will be a function of the tasks involved. Here we have just simple survey tasks, so it's not so high. You have these 2 seconds per question in common. And the reliability of individuals' answers should be increasing in self-knowledge and in effort, but only up to a threshold. So if an individual is below the effort threshold, he's going to use some heuristic or randomization strategy. This is going to produce a pattern of non-neoclassical measurement. But for a self-reported question, we claim to be able to account for this also. And if the individual does take the survey seriously, he'll answer the question according to the noisy signal that he gets on his latent traits. It's just going to be the signal is the trait plus some noise. And the variance of that will be decreasing in self-knowledge. So that's the simple one. And then you can get test-retest correlations. Simply, they'll be increasing in the variance in the population within the true values of the characteristic and decreasing in lack of self-knowledge. Okay, so we suggest that you add the reliability question to your surveys. You might use it to screen out individuals who give low reliability answers, or at least this robustness, or just fully maybe in sample collection. And we also think that you should carefully consider external validity concerns on a case-by-case basis. You might want to think about how effective this question would be in different samples, how representative the reliable sample is in your situation, and also whether the true relationship between outcomes and latent explanatory variables is likely to be highly nonlinear. And if you're losing representativeness and there is high nonlinearity in the relationships you're interested in, then you should be quite with screening out the unreliable individuals. All right, so in conclusion, test-retest correlations taken over a short period of time can be seen as a proxy for measurement there. Self-reported reliability of answers, we find, is the single best indicator and predictor for revealed reliability. And we propose a simple measure for this, which captures low reliability due to both lack of effort and or self-knowledge, and thus can be used to account for both classical and non-classical measurement there. We find that individuals who self-report to provide highly reliable answers have 40% less noise in their responses, which is equivalent to going from 1 to 5 indicators per construct. It's equivalent to that noise reduction. You also find that effort is beneficial, but only up to a certain threshold. Individuals who are above the effort threshold have 70% lower noise content in their responses, so this would be equivalent to going from 1 to 12 indicators per measure. So, in conclusion, a single question on reliability allows us to separate individuals who give highly reliable answers from those who do not, and we'd encourage you to use it and see how that does and understand this. Thank you very much. Yeah, please.
Did you think about asking two questions that separate those two components of self-reliability or self-reported reliability?
We did not. I think in a follow-up that would be interesting to do. And that is actually, so a few times before, and I think Stancheva has a review article on this. I think that's still a working paper. A few people before have asked only about effort. If you're giving low effort, please tell us. What we're doing, we think, is broader. We don't think this has been done before, and I think it would be interesting to try to separate that just in self-reports accounts. But we haven't done.
Yeah. I'm not sure how you'd ask, are you self-aware?
Yeah, which one probably needs to. So we're hoping this opens up additional research into exactly right. We had no prior on like which of these questions would be better. Is it the wording? Is it the place in the questionnaire, etc. There's definitely questions that this raises that I can't answer. Please.
Great talk, thank you so much. So I have two questions for you. The first one is, why did you focus exclusively on test-free test reliability as opposed to things like internal consistency, reliability, or split path?
Could you maybe remind me of what these mean?
Yeah, so like if you're, I think both of them would be focused on cross-sectional data rather than longitudinal, which I imagine is part of it. It's like other people primarily focus on the longitudinal stability to measure reliability, but theoretically, like you could also measure something like Cronbach's alpha by looking at the degree to which all of the items in the questionnaire come together and quantify measurement error that way as the inverse of that, or through splitting, let's say, a big five measure into like all the odd items and all the even items, and then looking at the correlation between those. Just ways of measuring cross-sectional reliability. One is like, I think there's two different ways of quantifying this, essentially.
Okay, I'll write those down. I'm coming more from the economic side of things. So the test-retest correlation, is that something that we've heard about and comments used with some of the other research too. So that's what we did. We thought that's a reasonable way to do it, but I'll write this down. I think that could be interesting to look at for the future. Thank you. So what do you call it again?
Internal consistency, reliability, and split path reliability. And I'm sure there's other.
Do you have a second question?
Yes, I have a second.
Sure.
So my second question is, it seems like this is a very practical and useful way to rule out data that have already been collected, but I'm curious if you have any recommendations. And obviously the data that you're presenting don't, specifically allude to this, so just like your musings on how we can encourage people to give more reliable answers rather than just like waiting for them to give unreliable ones and then deleting their data.
Right. Well, I guess two things, and one is what we're finding is that sort of probably reasonably early on, if you ask this question, you can detect it. So maybe you can, it's sort of like some of these screening things where like the survey providers, you want English speakers, and so the person said, oh, I'm not an English speaker at the beginning, you drop them. So maybe sometime early on, you could just ask this and wouldn't have to have them go through the whole circle. So that's one. Now, how to encourage people to give reliable answers? Well, so if you believe the self-awareness story, then there really isn't a very good one. There's just going to be some people who've engaged in more introspection, and so their answers are gonna give you a better idea of kind of what goes into the true relationship that you're looking at. Now, there is the effort part, right? Which likely the importance of that. So we've presented evidence on an online survey asking for a bunch of self-reports. That's not the only setting in which you're interested in your life. Right? You can incentivize experiments, you can do all sorts of stuff, you can do more complicated tasks. Presumably there, the effort threshold will be higher. So here we don't find incentives do very much, but we're looking at pretty low levels of incentives. But also it's a setting, right? So these things are hard to incentivize because there's no range. So maybe that's also something that you can look at. We didn't experiment with asking people in different ways. We sort of said the researchers, it's important. Thank you for trying to answer this carefully. I don't know how effective these things are, but I think some individuals they push in that direction. They read them, they think this actually has some relevance. So these would be kind of my ideas, but yeah. Sure. Now, there might have been a question here. So I think the person might. Any more questions?
Okay, thank you.
Anything online? Or?
Yeah.
No online questions.
No, you're
right?
good.